What if I told you that Earth was once a vibrant shade of purple? Not the green and blue marble we know and love today, but a world awash in violet hues. Sounds like something out of science fiction, right? Yet, this intriguing idea, known as the Purple Earth hypothesis, is actually rooted in real science and offers a mind-bending glimpse into our planet's ancient past. We're used to thinking of green as the color of life. Plants, with their chlorophyll, capture sunlight and power the biosphere. But what if, in Earth's infancy, a different pigment ruled the scene? What if, instead of chlorophyll, early life relied on a molecule called retinol? The answer, as we'll see, leads us down a rabbit hole of purple possibility. The Purple Earth hypothesis proposes that before the evolution of chlorophyll-based photosynthesis, early life forms might have used retinol to harness the sun's energy. This idea comes from the fact that retinol, while less efficient than chlorophyll, is simpler and likely showed up earlier in Earth's history. It's even found in a variety of organisms today, including the light-sensitive cells in our own eyes. So, how could retinol have turned Earth purple? Well, it all comes down to the way these pigments absorb light. Chlorophyll absorbs primarily blue and red light, reflecting green back to our eyes. Retinol, on the other hand, absorbs green and yellow light, giving off a distinctive purple hue. Imagine a world where the oceans shimmered with a violet tinge, and the land was dotted with purple microbial mats instead of lush green forests. To understand the difference between retinol and chlorophyll, imagine two groups of kids with different colored sunglasses. The chlorophyll kids wear shades that block out blue and red light, letting only green through. The retinol kids, however, sport sunglasses that block green and yellow, allowing mostly purple light to reach their eyes. Now, picture shining a white light on both groups. The chlorophyll kids would see a green world, while the retinol kids would see a purple one. It's the same sunlight, but the pigments in their sunglasses determine which colors they perceive. This is basically how retinol and chlorophyll work, just on a molecular level. They absorb different wavelengths of light, reflecting back the colors we associate with them. So, what might Earth have looked like during this hypothetical purple rain? Well, picture this: a shallow, sun-drenched sea just buzzing with single-celled organisms. But instead of the usual green algae blooms we're used to, these little guys packed with retinol would have turned the water a deep, almost surreal shade of violet. Now the land, still barren and volcanic, might have had patches of these purple microbes scattered across it, standing out sharply against the dark, rocky surface. It's kind of wild to imagine, right? This ancient Earth would have been nothing like the oxygen-rich world we know today. Retinol-based photosynthesis, unlike what we see with plants now, doesn't produce oxygen at all. So, the atmosphere? Yeah, it would have been more like a toxic cocktail of gases. Definitely not the kind of place you'd want to take a breath. And yet, even in that alien environment, life found a way. It managed to harness sunlight in a completely different way, and that's something that still fascinates scientists to this day. But you know, the reign of purple wasn't meant to last forever. Evolution, being the tireless tinkerer it is, eventually brought forth a new contender: cyanobacteria. These microscopic champs, equipped with chlorophyll, had a much more efficient way to soak up sunlight and turn it into energy. And the kicker, they released oxygen as a byproduct, a total game-changer for life on Earth. This shift led to what scientists call the Great Oxidation Event, which happened around 2.4 billion years ago. Oxygen, once super rare, started building up in the atmosphere, and that opened the door for oxygen-breathing organisms, like, well, us. As cyanobacteria spread and thrived, they slowly pushed out their retinol-based rivals. The oceans gradually changed color, shifting from violet to the familiar green we see today. Now, the Purple Earth hypothesis, while still up for debate, really sparks the imagination when it comes to life beyond our planet. I mean, if retinol-based life could thrive on early Earth, Could similar life forms exist elsewhere in the cosmos? Could there be planets out there glowing under a purple sun, with alien organisms using this alternate form of photosynthesis? So far, we haven't found any solid proof of purple life. But hey, the universe is massive and full of surprises. The search for extraterrestrial life is still going strong. And the purple Earth hypothesis is just one more reminder that life tends to show up in the most unexpected and colorful ways. So, the next time you're staring out at a lush green forest or swimming through the deep blue sea, take a second to think about Earth's long and colorful history. Our world, now bursting with greens and blues, might once have gleamed with a completely different hue. The purple Earth hypothesis, even if it's not fully proven, reminds us that Earth's past is full of surprises. Life, with its endless drive to adapt and evolve, has the power to paint the world in the most unexpected shades. Thanks for tuning in to Curiosity Corner. If your neurons are tingling, give us a like, drop your weirdest science fact in the comments, and let us know what strange idea we should dive into next. Stay curious, stay awesome, and we'll catch you in the next one.